Alright, it's been a while, but here we go. I'm going to show you solving systems of equations by the graphing method. So this is going to be the second method we've seen. For your big question, I want you to understand what is the importance of the point of intersection. Okay, so that we're finding today, and we're going to see, hopefully can explain to me what that point of intersection means. Way I'm going to show you this is solving by the graphing method by hand, manually. If you want to do it by calculator, I will try to hopefully get another video up about that later, but that will be like the second day. So we're going to try to do this manually. Alright, so we can see here we have an example, y equals x minus 2, and then the other one is y equals negative 2x plus 1. The idea is here that we want to graph these two equations, and then we're going to find the point where they intersect, and that point that they intersect is considered your answer, your solution. It's like the x and y points we found with elimination. So let's go with this. Let's go back to what we know about this. Okay, there's a 1 in front of this x, so we're saying 1 over 1, and remember, you're going to start at negative 2. So starting at negative 2 on the y-axis, my slope says I'm going to go up 1 over 1. Up 1 over 1. Go ahead and make some extra dots and keep continuing that line because you never know when that's going to be important. Up 1 over 1. This is a lot easier if you're doing this on graph paper than it is if you're trying to freehand it on your own. Okay, so we've got that. So I've got this line like this. And hopefully I can find all those points that make up that line and not have drawn them badly. Okay, now let's look at the negative 2x plus 1. Okay, so I'm going to start here at plus 1, positive 1, and I'm going down 2 and 1 to the right. And you can see they intersect right here. That is that point of intersection. Okay, I can finish out this line, down 2 over 1. I'll go ahead and make this one just by hand. But you can see that point right there, that's that point of intersection. That is my answer. So I'm going to put that in red. So what is that point? That is positive 1, comma, negative 1. And there's your answer. So what we're trying to do is, and again, this is why it's a lot easier on graph paper, because with graph paper, hopefully you won't get all crooked and crazy. So I highly recommend doing this one with graph paper. Okay, let's look at the next one. Okay, so I have y equals negative x plus 3. I'm going to start, again, think of that as negative 1 over 1. So go up 1, 2, 3, down 1 over 1. Because remember, negative means go down and to the right. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Notice how I'm continuing that. And think, you could also go opposite way. Up 1 to the left 1. Do the opposite. So notice how it still stays in the straight line, going up 1 to the left 1, up 1 to the left 1. Okay, so I think I've got all those covered. Make my line. Whoops. Let's try that again. Let's make a nice straight line. And there you go. Okay, now let's look at the orange line. Negative 2x minus 1. So here's my minus 1. Remember, this is down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Oh my goodness, it looks like I'm not going to intersect. I should put no solution. If these two numbers are not the same, they will intersect. You just need to go the other way sometimes. Okay, so keep that in mind. If the numbers in front of the x are different, there is an intersection. If the numbers are the same, then that means they're parallel, and that would be no solution. And if basically the equation all looks the same, that would be infinite solutions. But we'll come back to that later. So if I'm going down 2 and to the right 1 doesn't work, maybe going up 2 and to the left 1 works. Up 2 and to the left 1. Oh, look, that looks like it's getting closer to the other line. Up 2 and to the left 1. Up 2 and to the left 1. And finally they intersect. So you can see here, this one intersects right there. That one point right there. So what I would say is, let's see what that is. 1, 2, 3, 4, negative 4. 1, 2, 3, 4, 5, 6, 7, positive 7. So you just found that point, negative 4, positive 7. So you see, now we're getting back to the graphing and why manually able to understand graphing. Finding that slope and y-intercept is so important. All right, last example here. Y is equal to 1/2 x and y is equal to negative x plus 3. 1/2 x. Start at, do you see a number after the x? There is no number here. So start at 0. Go up 1 over 2. Up 1 over 2. Up 1 over 2. Because they're both positive. You can also do the opposite and go down 1 to the left 2. Down 1 to the left 2. Notice if I went up and to the right, going the other way I go down and to the left. Both opposites. Okay, so that gives me a line that looks something like this. Having a ruler might even be helpful on this. Okay. Okay, the other one starts at positive 3, 1, 2, 3. Negative x, what does that mean? Well, put a 1 there because you don't see a number. Negative 1 over 1. Down 1 to the left, or to the right 1. Down 1 to the right 1. I found my intersection right there. That point right there. And so that point right there would be, according to this, positive 2, positive 1. Okay, and that's really it for graphing by hand. Notice that I had these already set up for graphing. Y equals type of situation. So for graphing by hand, I like to have them in a y equals type thing. So for graphing, I like to have this situation where they both say y equals. That way it's already set up for graphing. Notice that the ones we were doing with elimination were in standard form, where x and y were on the same side. If there are any questions, feel free to ask in class. Make sure you've made note. Hopefully you were taking these in Cornell style, so you do have, if you have any questions, you wrote them down. Anyways, thank you very much, and I will see y'all when I see y'all.